Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be electrolysis. So this chapter will be a little bit confusing like the one in the redox. So over here you need to know the confusing part is assigning the cathode or the anode and who goes where. So please stay with me. So electrolysis is the process of using electricity to break down a compound. Using electricity, lysis means to break down something, like the word lyse, and it's commonly used for extracting useful elements from compounds. So this is basically how to draw a circuit. This is the long line represent the positive end of the battery and the short line represent the negative end of the battery, and these are the wires, and electrons are attracted to the positive end and exit the negative end. So always remember that. And because of this direction of the electron flow, the compounds in the electrolyte, the components of the electrolyte will go to different electrodes. So during electrolysis, anions go to the anode. And because the anions are attracted to the anode should be the positive side. And anions will go to the anode to give up electrons. Therefore, oxidation happens here. And on the other hand, the cations go to the cathode. The cations will go to the cathode to receive electrons. At this side, the reduction occurs. So as a general rule of thumb, just remember that cations go to the cathode, which is the negative electrode, and the anions go to the anode, which is the positive electrode. And at the electrodes, the act of gaining or losing electrons is called discharge. So looking at this example of electrolysis of molten ionic compounds, the examples you only need to know is the binary compounds. A binary compound is a compound that contains two elements, sodium chloride being an example because it only contains sodium and chloride. So what happens when molten sodium chloride is electrolyzed? Within this system, only ions that exist will be the sodium plus ion and the chloride minus ion. So cations go to cathode, which is the negative electrode, and ions go to anode, the positive electrode. So the sodium plus goes to the cathode, chlorine minus goes to the anode. And as such, these discharge reactions take place and the overall reaction will look like that. For this reaction, the electrode should be an inert kind, and inert electrode are ones that do not participate in the reaction. Examples are the carbon ones and the platinum ones. So they just help to conduct the electricity. They remain unchanged at the end of the reaction, the experiment. Platinum, just so you know, is very unreactive. They are even lower than gold in the reactivity series, which this series is very important in this chapter. We'll talk about it later. So now we move on to the electrolysis of aqueous solutions of compounds. Initially we talk about molten. There's only the element that exists. Here aqueous is a little bit more complicated because water is part of the aqueous solution. They can also dissociate to form ions. Water forms H plus and OH minus that will affect the resultant products that are collected at the end of the electrolysis. So a common example with electrolysis of dilute sodium chloride. So the ions in the system are as such: sodium plus, chlorine minus, H plus, OH minus. So same, cations go to cathode, anions go to anode. So H plus and Na goes to the cathode, but due to selective discharge of ions, only the H plus will come together to form H2 gas. And at the anode, OH minus and Cl minus will be attracted, but only the OH minus will discharge ions to produce oxygen gas. So the overall reaction will be this. So looking at this, the overall reaction shows electrolysis of dilute sodium hydroxide is equivalent to the electrolysis of water. So the sodium chloride is only here to help provide some ions to increase the conductivity of the water solution to help water undergo electrolysis. So because there are more than one ion going to a particular electrode, there will be a understanding required of selective discharge. And how does that work? For the cations is quite easy. It's just the reactivity series. The more unreactive the metal is, the easier it is to be discharged in the electrolysis. And for the anions, it's the same. The less reactive the halogen ion is, the easier it is to be discharged. And of course, easier than the iodide ion will be the hydroxide ion. So this is a list that you need to be familiar with. And do note that sulfate and nitrate ions do not get discharged during electrolysis. And one of the commonly asked equations will be the equations at the electrodes. So one of them is this. This is very important. This is what it will look like for the halogen equation, and this is what it will look like for the metal on the cathode. So other than the position in their own reactivity series, the concentration of the anion also plays a part. So if it is a concentrated solution containing chloride ions, the chloride ions will be discharged. So I felt that while reading the textbook, this is a very good sequence of events to follow while determining selective discharge. First, you identify the ions present, then you determine what happens at the anode, then you determine what happens at the cathode, and finally determine what are the resulting cations and anions in the solution after electrolysis. Then the reactions can be summarized. So look at this example of electrolysis of aqueous copper 2 sulfate using inert electrodes. So by looking at the equation, this sentence, you know that it's aqueous, so it does contain H plus OH minus and also CO2 plus and SO4 2 minus. So the first rule is to identify who are the ones participating. That's the first step. Second step, what happens at the anode? There are OH minus and SO4 2 minus. So you have to determine who gets discharged. So of course, because sulfate, the ions does not get discharged, only the hydroxide gets discharged. So this is the equation, and sulfate ions remain in the solution. Next, step 3, at the cathode, determine what happens. Cations go to cathode, so H plus and CO2 plus goes to the cathode. But because CO2 plus is lower than hydrogen in reactivity series, CO2 plus gets discharged. This is the equation. As a result, H plus ions remain in the solution. And because H plus and SO4 2 minus ions remain in the solution, the remaining solution gets more and more acidic. So summarized equation will look like that. Initially, it starts with these two guys. After electrolysis, this guy gets discharged, this guy gets discharged, and this one is the resultant one that comes together. Okay, so what about the concentrated sodium chloride solution? So same, find out who are the players, what happens at the anode. Anions go to anode, but because it's concentrated, high probability that the chlorine gas is discharged. OH remains. And what happens at the cathode? Cation go to cathode, so these two guys go to the cathode, and H plus ions accept the electrons more readily than Na plus ions, therefore H2 plus gets discharged. So Na plus remains in the solution. So because of these two remaining in the solution gets more and more alkaline through the process of electrolysis. And always understand that, like the gases chapter, calculating gases, the resultant products, if they are in gases, they will be produced in comparison to their molar volumes. So if in the earlier example, if we electrolyze concentrated sodium chloride solution, we will get 1 volume of hydrogen, 1 volume of chlorine, or if it's dilute, it should be 2 volumes of hydrogen, 1 volume of oxygen, because it's equivalent to electrolysis of water itself. And so why do we study electrolysis for? Firstly, it's for the purification of items due to high demand for pure metals for circuitry and users. So one of them is the electrolytic purification of copper is very important using aqueous copper 2 sulfate and copper electrodes. So in this case, because it's copper electrodes, they also participate in the reaction as well. So this is how the circuit looks like. The cation goes to the cathode, and this is the reaction. So the cathode will become bigger and bigger, heavier and heavier, and the anode will be discharged into the solution through this equation. It gets split, the electron goes upwards to the positive end of the terminal, and the positive ion enters the solution, and the solution will provide the ion to the cation to the cathode. And because of this, do note that the metal cation that is inside the solution must be the same one that is being used as in the electrode. So if it is a copper cathode, copper anode, your solution should have a copper cation. For example, copper sulfate, because the anode is going to disintegrate, get lighter and lighter, and the atoms goes into the solution. The solution will then provide the cation to the cathode. So because of this, the anode passes 1 cation into the solution passes 1 cation into the cathode. There's no net loss of cation from the solution. The color and concentration of the ions in the solution should remain unchanged, relatively unchanged. So this is, like mentioned earlier, used to purify copper. The impure copper is at the anode because the cation gets to split, and the pure copper cathode should be used to collect the pure copper cation to be discharged as a copper metal. Then the impurities will be sunk or floated. You can see many restoration YouTube videos. They are also using electrolysis to purify the items that they are trying to restore or plate them, which we'll be talking about now, electroplating. So electroplating helps to give the material a nice outer coat, prevent rusting. Silver plating, gold plating can be used to make an item look expensive. Chrome plating makes it looks good, prevents corrosion. So like mentioned earlier, the item that you want the cation to be deposited on should be at the cathode, because cations go to cathode. The metals that is going to be deposited on the item exists as a cation. So an example will be copper plating. Look at this. The item should be at the cathode, and the plating metal should be at the anode, used to provide the cations into the solution. So the solution should also contain the metal cation that you want, that is copper 2 sulfate. And because it is reaction at the anode, is that the electrode itself gets disintegrated, gets dissolved into the solution through electrolysis. It does not produce oxygen through the discharge of OH- ions. Okay, hopefully that wasn't too confusing. Okay, we move on to simple cells. So you may have in your earlier years seen some kind of little experiment that uses lemons or any citrus fruits to be used as a battery. This is what we are going to go deep dive into, and we will know that actually it's not the lemon that is conducting or providing the energy, it's the difference in the electroconductivity of the metals used. So what is a simple cell? This is how it looks like. So as compared to the earlier diagram where the battery pushes the electrons around, in physics we call electromotive force to push electrons around a circuit. In this case, it's the difference in reactivities of the two metals used as the electrode. So common example will be zinc and copper, because they're easily found around you. And zinc is the more reactive metal. Zinc therefore likes to give up electrons. Electrons go upwards towards the copper electrode. So because it passes through the voltmeter, it registers a reading, and as a result, the electrons come towards the copper electrode, and the H+ ions are the one that takes up the electrons. So oxidation happens here because loss of electrons. Reduction happens here at the cathode because electrons are gained here. So here, zinc acts as the negative electrode, copper as the positive electrode. So electrolyte usually is something that conducts and dissociates its ions inside, so usually it's a dilute acid. So this is how a simple cell is constructed. Instead of the battery giving power, it's the difference in reactivity of the metals that will push the electrons around. Zinc being more willing to push out its electrons as compared to copper will create some kind of a power imbalance. If you are using both copper, then there's no power imbalance, they are the same. So because zinc dissolves in this cell and copper forms at the copper electrode, the overall reaction will look like this, and oxidation and reduction occur together, so it's a redox reaction in a simple cell. So always remember that the more reactive metal contributes electrons to the less reactive metal. So the flow of electrons is from more reactive to less reactive. More reactive becomes negative electrode, and less reactive metal is the positive electrode. So if we change the electrolyte, the liquid inside, then circuit still runs, but the products will be a little bit different. Over here would be the same. Zinc gives up electrons, and on the other hand, the cation go to cathode, so therefore copper 2 gets the electrons and deposit as a copper metal atom. Overall reaction will look like that. And the further away the two metals are in the reactivity series, the voltage registered will be greater, because the power imbalance is so great that one wants to push out a lot, the other one wants to receive. So you don't have to commit to memory the differences. You just have to know the basic rule of thumb is the difference in the distance in the reactivity series. The greater the distance, the higher the voltage. And if it gets really confusing, do comment down below your questions. I'll be glad to answer them. One of the very interesting questions I came about will look like that. In an electrolysis experiment, the same amount of charge deposits 16 gram copper and 6 gram titanium. Charge on copper ion was 2+. They're asking for the charge of the titanium ion. So same amount of charge means the number of moles of electrons that is being provided for. Okay, so 16 gram copper, the number of moles of
copper will be this. The copper ion was a 2+ ion, so it consumes this amount of electrons. So that's the amount of charge they are talking about. So this amount of moles of electrons will also provide for 6 grams of titanium. So 6 grams of titanium is this amount of moles of titanium ion, and divide them up, the answer will be this. Titanium will be 4+. And in this question, this is called a bridge. Okay, if the solution goes across, it's called a salt bridge, but this is not really. It's just a bridge. Just know that it's not a salt bridge, just a bridge. So do know that the electrons still flow in this direction, and the names, the cathode, anode, will still have the same configuration. So electrodes Q and S increase in mass during electrolysis. No gas given off. The increase in mass of Q is greater than increase of mass of S. So in this case, the reasoning will be this, because the amount of charge that is running through at any one point of time will be the same. The rate of electron movement will always be the same. So if the one of them gains more in mass, that means the atoms, the cations used are different. So the rate of gain of weight will be different. So a question will also look like that. Molten lead to chloride electrolyzed. So the cation goes to the cathode. The cathode is the negative electrode, and the cations will go there and collect electrons. And in this question, so same. The cations, the metal ions, will go to the cathode. Cations go to cathode, negative electrode. To collect electrons means reduced. So these are commonly tested, commonly asked, and you have to be pretty clear of the language that is being used. If you have further questions, you can comment down below.
And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!